Okay, this video is going to be about percent error and percent change. I'm going to go through a couple of definitions and then a couple examples, so it should be a pretty short video. Okay, two definitions. Percent error, it measures the inaccuracy of a measurement. Kind of obvious, right? The error. It tells how close you came to the actual measure. Okay. Percent change is the amount measured by percent, okay, of something that increases or decreases from its original amount. Okay, so it's how much something got bigger, how much something shrank from its original measure. Okay, so two formulas, and they're both very, very similar. Percent error formula is you take the difference of the two numbers, the error and the actual thing, and then you divide it by the actual. And then you multiply all of that by 100. Okay. Similarly, for percent change, it's the difference of the two numbers, what it measured originally and whether it went bigger or smaller. Okay, and you just make it so that you can either say the absolute value of that or just take the difference, take the bigger number minus the smaller number. And it's going to be this time over the original times 100. Okay, and we'll do a couple examples of each, and so you'll see how to apply it. All right, so first example, we'll talk about the percent error problems. Okay, suppose, there's your one. Suppose a bag of chips says it weighs 8 ounces, but really when you weigh it, it's 8.2 ounces. What's the percent of error? Okay, write down the formula. You get the difference over the actual amount times 100. Okay, so that the difference between 8.2 and 8, I just did 8.2 first. It doesn't mean you always have to put the first number minus the second number. It's just I just do the bigger minus the smaller. That way it's always going to be positive. And then you'll know whether it went up or down. Okay, all right, and it's going to be over the 8, which is the actual. Oh, wait a minute, I made a mistake. It's supposed to be 8.2. Because the actual one is 8.2. So this number is going to be a little bit off, and I'll grab a calculator and we'll actually do it. Okay. So make sure you're really careful about that. So it's going to be 0.2 divided by 8.2, which is going to be, and you can just always do these right on the calculator, 0.2 divided by 8.2, and then times 100. So it's going to give us very close. It'll give us 2.43. So we'll just lower this 1/10. So it's going to be 2.4 because 2.43 does not round to 2.5. So it's a 2.4% error. And a lot of these percent error problems, the difference is just in a tenth or in a hundredth of a decimal of a percent. I mean, so it is very close, and the answers are all going to be very close together. So you have to be very careful. Okay, so what we learned from that experience was that, remember, it's always going to be the difference of the two, which is pretty easy to figure out. But then the problem that is tricky sometimes is the actual. And the actual is going to be what it actually weighed, the actual thing. So here it was 8.2, not 8. Okay. Same thing for this one. And a lot of these are going to be with chemistry experiments you're going to do in high school. For number 2, it says the boiling point of ethyl alcohol is 80 degrees Celsius. Okay. Which is a predicted. You have a book that tells you basically what's the standard predicted degree. And Lance measured his sample to be 75%, so his actual measurement was 75 degrees. What is the percent error? Okay, again, the formula. And then you fill in the difference is easy to find. The trick is what goes on the bottom. And always make sure it's the actual one that goes on the bottom. So in this case, it'd be 75. And then times 100, and when you do it out, it's going to be 0.06666 repeating. So you just round that to 6.7%. Okay? Next one. Okay, now we're going to do percent change problems, 2% change problems. Okay, at Target, a shirt costs $25, goes on sale for about 15 bucks. What's the percent decrease? It's always good, guys, to estimate a little bit. If something goes down like $10 and it's only $25 to start with, it's going to be a pretty good discount. Okay, and here we see it ends up being 40%. But to show how to do it, you do difference over original times 100. So you do the difference. Again, the original is going to be the one to have to double check on. So the original is how much it cost at the beginning. Okay, the first amount. And here it was $25 at the beginning. So you're doing 10 over 25 times 100 ends up being 40%. Okay, the next one. What is the percent change from 180 to 54? Okay, again, we're going down, but it doesn't really matter. You just know that it's a decrease. Okay, and if you think about this again, man, that's quite a big discount if you want to talk about money, if that was the case for money, or just quite a big change, quite a big decrease. Like 54, that difference there is over 100 difference, and 100 compared to 180 is almost half. So you're going to get quite a big difference. So again, you do that. So it's always good to kind of see where am I going, what will the answer be about. So when you get it, you can say, okay, I think I'm right. All right, so you do the difference, and again, it's over the original. Usually the original will have, it's going to be the number after the word from. When you have the word from, that means that's from where? From the original. Originally it was from, you know, they say I'm from Ohio. Well, you originally were from Ohio. So that would be the original, okay? Whatever number follows that word from. So that was 180, and then you took the difference and divided by 180, got 0.7, moved it over 2 places, and got 70%, which we predicted it would be a big percent. Okay, that's it.